Alrighty, everybody. I think we've been skating by too easily um, lately. We're on an extension, 3.4b, but this is not going to be a simple, quick one. We're doing compound inequalities, which are basically multiple inequalities that have been joined together using um, and or. All right, so it's multiple equations happening at one singular time. So let's take a look at exactly what that means. Solutions of compound inequalities with and consist of numbers that are solutions of both inequalities. So if I have x is greater than or equal to 2, we know that that's a closed circle on 2 pointing to the right. And if x is less than 5, that's a closed circle, an open circle on 5 pointing to the left. But when I make a compound inequality using both of those, x is greater than or equal to 2 and x is less than 5, the solution is only the places where those two solution sets overlapped, between 2 and 5 basically. Now, when it comes to the solutions of an OR type equation, say I have y is less than or equal to negative 2, and I have y is greater than 1. Less than or equal to negative 2 means closed circle on negative 2 pointing to the left, and greater than 1 means open circle on 1 pointing to the right. Now, solutions where it's an OR means that it has to be, either all of these things pointing to the left after negative 2, or all of these things after 1 pointing to the right. All right, so it's adjoining two sets of inequality together. So in example 1, we're basically going to translate some verbiage into mathematical sentence. So a number x greater than negative 8, less than or equal to 4. Okay, let's see what we can do here. A number x, easy enough, is greater than negative 8 and less than or equal to 4. Okay, now I could have done this in the way that I did, which is kind of putting it all together in one little piece, or I could have separated them entirely and just used the word and. So I had x is greater than negative 8 and x is less than or equal to 4. I could have done it that way as well. I prefer to write it as one coherent statement, and that's just a more, I guess, professional way of doing it, but that's up to you. Now, in terms of graphing the inequality, let's go ahead and make a number line. I'm going to need as far down as negative 8 and as far up as positive 4, and then maybe some other numbers, somewhere around there, like negative 10 or 2 or 6, just to give me, some bearing. And then I can start to graph. X is going to be greater than negative 8, so open circle. It's going to be less than or equal to 4, so closed circle. And where do these two things overlap? I'm going less than 4. I'm going greater than 8. It's this area right in between the two. Fantastic. Now let's look at the next one. A number y is at most 0 or at least 7. So at most. At most means that the y is going to be less than or equal to, because it can't be any more. It has to be at most 0. And then at least means greater than or equal to, because it can be more, it can't be less than 7. It has to be at least 7. Alright, so we have an or in between this time. Let's look at what this looks like on the number line. I'm going to go have 0 here. I'm going to have 7 over here. There's something like 6 and 8 and negative 1. And heck, why not put 1 over there? Now, y is going to be less than or equal to 0, so that's a solid and pointing to the left, or y is going to be greater than or equal to 7. So, or equal to means solid, greater than means to the right. So that's what my solution looks like here. Now, let's look at solving compound inequalities. That's where things begin to get a little bit trickier, because we essentially have three parts of an equation happening at one time. All right, I have like the main equation in the center, and then two numbers off to the side. So, like we always used to say that we need to keep things balanced in the equation, we still need to do that, but we need to keep it balanced in three different places. So I still want this to have just an x right in the middle. So I want to move everything away that's not an x, but when I do subtract 1 right there, I also have to subtract 1 on the right, and I have to subtract 1 on the left. So that means that in my next step I have negative 4 less than negative 2x less than or equal to 8. And then in my next step, yep, I want to divide by negative 2, but if I divide by negative 2 there, I have to divide by negative 2 everywhere, which means now, it's a negative number. I'm dividing by a negative, which means I'm going to be switching all of the signs. This becomes a positive 2, switch the sign. This becomes just x, exactly like I wanted it, switch the sign. And this becomes negative 4. Fantastic. I have got it down, and now all I need to do is graph it. I'm looking at the x is less than 2, but it is also greater than or equal to negative 4. So I have negative 4 down here, I have 2 up here, and I know that my x is going to be less than 2, so open circle on 2, pointing that way. But it's also going to be greater than or equal to negative 4, so close circle on negative 4 and pointing that way. It's an AND situation, so the overlap happens directly in between the two. That is what my solution looks like for this one. Now let's look at solving a compound inequality that has OR. ORs are a little bit different because it's mainly just two different equations happening simultaneously. Where I had this one and I was kind of working with all three at the same time, ORs are a little bit more relaxed and you can work with them bit by bit. So over on this one, I'm just going to solve this one simply by adding 5 to both sides. And I get 3x is less than negative 3. And then I divide by 3. Now, remember that even though this number is a negative, the number I'm dividing is not, the number I'm dividing by is not negative. So the sign does not change. X less than negative 1. And over on this one, I am simply going to add 1 to both sides so that 2x is greater than 6, divide by 2, and x is greater than 3. And now I can graph. Number line, I'm looking at x being less than negative 1 and x being greater than 3. So I'm going to have negative 1 over here. I'm going to have 3 over here. And I know that it is going to be less than, so open circle pointing to the left, and greater than, so open circle and pointing to the right. And there is my OR statement. Not too bad, huh? Now we have just a little bit more before we're done, because absolute value inequalities are exactly like compound inequalities. They're just kind of masked. Okay? There's a little bit of information behind how they're masked that we need to go over first, and then we'll jump into it. So, an absolute value inequality is an inequality that contains an absolute value expression, right? So the absolute value of x being less than 2 and the absolute value of x being greater than 2 are the absolute value expressions. But they vary very, very much just because one says less than and one says greater than. So when the absolute value is less than, it's just like having an AND statement. When the absolute value is greater than, it's just like having an OR statement. That's what these two images are telling us. All right? So when I look at this first example, the absolute value I'm looking at says that it's less than this number, which implies to me this is an AND type situation. And one of the situations is x plus 7 is less than or equal to 2. And the other situation is that x plus 7 is less than or equal to negative 2. All right, so we have one situation where it's exactly what's written, and then we have another situation where I flip the sign and I've made the solution negative. Now this one over here, let's just set this one up as well. Says that the absolute value is less than 0. So less than implies that I'm looking at an AND type situation where I have 8x minus 11 less than 0 and 8x minus 11 greater than 0. Perfect. Now let's do some solving. This is going to be minus 7 and minus 7, which gets me x is less than or equal to negative 5. And over here, minus 7 and minus 7, which gets me x is greater than or equal to negative 9. Beautiful. Now let's solve the other one. I'm going to add 11. And I'm going to add 11. And what do I get? I get 8x less than 0. Oops. 11. And 8x greater than 11. I divide by 8, divide by 8, divide by 8, and divide by 8. X less than 11 over 8, and x greater than 11 over 8. Now, the thing that I want to ask about part B is, what do we think? Do you trust me? Is it correct? Is it true that x is less than 11 over 8 and that x is greater than 11 over 8? Could it be possible that the absolute value of 8x minus 11 is less than 0? Remember back to absolute values when we first did them. Is that possible? Is it possible for the absolute value to be a negative number? That's what this says. Absolute value of this thing in here will evaluate to a negative number. All of this, there was no need for it. No solution. Now, it's a little deceiving. So it can be deceiving that you came out with some sort of solutions down here, but we really need to wrap our heads around, what is it that I'm actually doing, instead of, I know that this is the process that I take to go about doing this. We really need to be conscious of what's happening. So now let's look at this other one down here. This one is very, very interesting because there's more going on than just the absolute value, right? There's 4 times the absolute value, and then there's also plus 1. So what we want to do is try to clear everything away first by subtracting 1. So I get 4 times the absolute value of 2x minus 5 greater than 28, and then divide by 4. So I get just the absolute value of 2x minus 5 greater than, and then 28 divided by 4 is 7. So now I have the absolute value just alone, just by itself, and I can look up here. The absolute value is indicating greater, so this is an OR type situation. 2x minus 5 is greater than 7, or 2x minus 5 is less than -7. And I solve. I'm going to add 5. So I get 2x is greater than 12. And over here, I'm going to add 5. So I get 2x is less than -2. And then I divide. Divide, divide, and divide. So that I get x is greater than 6. Or x is less than -1. And I have my solutions. And that's all I have for compound inequalities. Remembering that compound inequalities and absolute value inequalities kind of go hand in hand. And the tricky thing about them is that you have to remember that the sign of the absolute value, whether it's being denoted as greater or less than, really changes the entire problem. Alrighty, so work on your assigned problems. I will talk to you guys all in class. When you have questions, make sure you write them down. And we'll see you then.